Hello guys, I hope you're doing fine. So in today's video, it will mainly be concentrated on the basics of layout designing and about the different layers that are available and how a transistor is formed. So coming to the basic layers, we have all these layers that are available to us, the N and P implants, the N well, the polysilicon, metal oxide, and a contact. So coming to the P implant and N implant. There are two ways of adding dopants to the substrate. The two ways are diffusion and ion implantation. So what happens in diffusion is the silicon wafer is placed in a furnace with a gas containing the dopants. So this furnace is heated around 1000 degrees centigrade and it is inserted into the furnace with the gas that contains the dopants. So coming to the ion implantation, the dopant ions are accelerated with the help of an electric field and it is blasted into the substrate. So coming to the next layer, that is the N well, if we consider a PMOS, the source and the drain are made of P plus, but whereas the body is of N type. So the N well comes into picture when we have a PMOS and the N well is nothing but the substrate of the PMOS. Coming to the polysilicon, that is denoted in green, it is the gate of the transistors. So it is a polycrystalline silicon that is placed over the oxide layer. So this forms the gate of the transistor. Coming to the metals, we have many different layers of metals that are present, and these are used to make or to route interconnections between uh, 2 points. And if we have two metal layers, suppose metal 1 and metal 2 layers, they are separated by a layer of oxide. So coming to the oxide, this oxide is in a red color. It is nothing but the silicon dioxide. So it is the insulator. So you can see the silicon dioxide that separates the gate and the channel. So this is nothing but that silicon dioxide. Coming to the contact cut, that is the white box. So these white cubes indicate that the oxide is etched and there is a connection to the source or to the drain of the transistor. So wherever you find these white cubes, that indicates that the oxide is etched. The oxide in that white cube is not present and there is a direct connection to the source or to the drain of the transistor. So now let us go ahead and look at a photo of a MOSFET. So as you can see, there are different layers: the body, the source, drain, oxide, and gate. This is an example of NMOS where the source and the drain are made of N plus regions. The body is of P type and there is oxide that separates the gate and the channel. And the source and the drain, you can see that there are two contacts that are directly in contact with the source and the drain. And the gate is of polysilicon. It is grown over the oxide and the oxide insulates them. The gate and the channel acts as a capacitor. So similarly, there are the same layers to a PMOS, except that the source and the drain are P plus, the body is of N type. So let us consider an example of a PMOS transistor. Here you can see the purple color is nothing but the N well. It is the substrate or the body of the PMOS. So over this, there exist the source and the drain that are formed by ion implantation or diffusion. They are given by this brown color, and now the oxide is laid over the wafer. So the oxide is grown over the body of the transistor, and it is given by a red color. Now coming to the source and the drain of the transistor, the oxide is etched, so there becomes a contact between the source and the drain, and it is given by this contact which is in white color. Now to form the gate connection, there exists a polysilicon of green which indicates the gate terminal, and this there must be an interconnect, or there must be some form of conductor to connect the source and the drain, and that is given by a metal. So we use metal one layer to form the interconnects. So I hope everyone have understood about how a transistor is formed and about all the layers that are present in a transistor. So this wraps up the introduction to layout, and in the future videos we will be designing the layouts of the inverter, common source, NAND gates and op amps. So continue to stay tuned. Thank you for watching.